Hello everyone, I am Mandeep here. In this video, you are going to learn about basics of data structure with me. So let us begin with this video. So before going further, we must be aware about what is data structure. Data structure is a logical relationship between some organized form of data. So we have some data, we will organize it into some manner so that we can show the relationship between the elements of data. So data structure is representation of logical relationship existing between individual elements of data. On the other hand, we can say we can organize data into any manner so that can be sorted in any manner, like we can sort it in ascending order, we can sort it in descending order, so that we can show the relationship among data elements. Let us take an example here. If we are having some numbers 5, 8, 2, 3, 1. So here we can see there is no relationship between data. Like I am going to arrange it in this ascending order. 1, 2, 3, 5 and 8. So in this manner, here every element is lesser than its next element. Like 1 is less than 2, 2 is less than 3, 3 is less than 5. So it is ascending order list. So data structure can be classified into two types. First one is primitive data structure, second one is non-primitive data structure. Primitive data structure can be further classified into four forms: integer, float, character and pointer. Integer are the whole numbers that does not contain any fractional part, like we can say 5, 3, 2, anything. These are all integers, all 0 from 0 to 9. These all are integers. In the float, there is like decimal values, 5.0, 5.5, any values containing decimal. These are also called real numbers. Next one is character data structure. Character is any single character in single quotation mark. Here A is called character. Next one is pointer. Pointer stores the address of any variable, like we can say x. If x is a pointer variable, so we will represent it in the form of this, like we will put the asterisk sign above before that element. Like x variable is a pointer, then x will store memory address of y. Here this is AND symbol used for y, and pointer stores the address of any variable. Next is classification of data structure. Next classification is non-primitive data structure. Non-primitive data structure is further of two types: linear list and non-linear list. Linear list is having data arrays, linked lists, stacks and queues, and non-linear linked list is having graphs and trees. I will be covering them further. I will elaborate all these things. First type of non-primitive data structure is arrays. Array is collection of elements of same data types. Like we can have roll numbers. Roll numbers are of same data type. Roll numbers are of integer data type. Then we can have some more example. We can have array of names. So names array will be of character data type. We can collect some data of similar type and give it a single name, that is called array. Arrays having finite number of elements. The index of array always starts with 0 and it ends up with n minus 1. If we are having 5 elements in array, so its index will be from 0 to 4. Let us take example of array. Here we are having array 0. 0 is the index of first element of this array. This is the name of array and this is the index of array. Like we are having an array of the index 0 to 5. So we can store 6 data elements in this array. And to access these data elements, we can write here the index. If we have to access something present over here, so we can write here array 3, so that we can access the element present in the third location of this array. Next one is linked list. Linked list can be defined as collection of variable number of data items. Any number of data items can be available. Like array was finite set of data elements that is fixed. We have to fix the size of array in advance, but in linked list we need not to mention the size of linked list in advance. We can have any number of elements in this list. Let us see the example of linked list here. Linked list is having two nodes, two parts in single node. One part is having information like data is stored here. Second part is having pointer, or we can say address of the next node. In the same way here 23 is stored and it stores the address of 55. In the same way 55 is stored in the first part, the info part, and next part here is pointer pointing to the next node. So if there is no further node at the end, so we can mark it as null node, because we can mark it as null pointer because this pointer will end up here only. There is no next node in this list. Next are the stacks. Stacks work in the last in first out principle, LIFO principle, in which last entered element comes first out. Like if we are having example of stack, whatever enters in the stack in the last, that will come first. Let's see with this example. Here we are having empty stack and we push 1 into it. Push is the insertion operation and pop is the deletion operation, in which we push 1 into the stack, then we push 2 into the stack, then last third element is entered in the stack. Now if we have to delete an element from the stack, then 3 will be the one that will go out first. Next non-primitive data structure is queue. Unlike the queues, unlike the stacks, queues are first in, first out. Whatever enters first in the queue, it will be the first element that will be out from the queue. So we can have two ends of the queue. One is rear end, next one is front end. We enter all the elements from the rear end and delete all the elements from the front end. Like we can see in this example also, we are having front end from where the elements are deleted. DQ operation is performed at the front end and NQ operation is performed at the rear end. Rear end is that end from where we will enter the elements. Let us take an example of railway reservation row. Whosoever is standing in the row first, he will take the ticket first and then he will go out from the row. So queues works in first in, first out order of principle. It works in FIFO principle. So whatever enters the queue, it will go first only. Next are the trees. Tree can be defined as finite set of data items. Like arrays, here also trees are also finite set of data elements. Those are called nodes. Nodes will be connected with the edges, and trees always follows a hierarchical system. Tree is non-linear type of data in which we organize the data. We do not organize this data into a sequence form. We organize this data into a hierarchical form. Tree always follows the hierarchical relationship. We can see the example here also. This is the root of the tree. These are intermediate nodes. These are intermediate nodes. And these are further next level intermediate nodes, and last are the child nodes, or we can say terminal or child. We can take our example from daily life, like we are having grandparents. Here the first level, 0th level, we are having grandparents, then our parents, then we, the children, then the next generation, like in human beings. So we can take similar example from our real life to represent the trees. Last data structure is graph. Graph is mathematical, same as trees. Graphs are also non-linear data structure, but the difference between trees and graphs are that trees does not form any loop, but in graphs there can be some loops, like if we started from one position, like if we started here, from here, we may end up there only. But in trees, tree is called open loop. Like here, there will be no connection between these two nodes. So this is the difference between graphs and trees. Graphs can also used in geography, chemistry, engineering sciences. Any graph can be defined as like this. G is the set of, G is the graph here, G is the set of vertices and edges. These are called vertices and these are called edges. These are called vertices, these are called edges. This is the example of graph. Here A, B, C and D are vertices that are combined, that are joined using these edges, which here we have mentioned the weight. That can be the difference between A or B, like the distance can be defined using weights. That can be anything. Here is another example of weights, another example of graphs. Here we can see these are directional graphs, where we can see we will move from A to B, then from B to C, then from C to D. But this is unidirectional graph where there is no direction provided. 1, 2, 3, 4, 0, any vertices are present, those are connected with the help of edges. So in this video, we have covered the basics of data structure. I hope you must have understood the concept of data structure. So in the coming videos, I'll be making a series of the concepts of data structure. Whatever we have studied in this video, I will be covering them in the coming videos, so that you can have a deep knowledge of data structure. Thank you so much for listening. Thank you. You can subscribe my channel for further videos so that you can get the full series of data structure, whatever I will be covering in my I will be posting in this channel. Thank you so much for listening. Thank you.